All right, let's dive right in. Today we're going on a really important journey for any mobile developer, especially if you're using Delphi. We're going to talk about how to take an Android app from feeling sluggish and clunky to being incredibly fast and seamless. And look, this isn't just about fixing a few bugs. It's about a complete strategic rethink, from the user interface all the way down to the metal, the native code itself. Let's get into it.
Let's kick things off with this fundamental truth. The source material for this explainer puts it perfectly. Performance is everything, right? But it's only there to serve the user's experience. A super fast app with a confusing or ugly interface, it's a failure. Just like a beautiful app that constantly freezes is a failure. They are two sides of the exact same coin. And today, we're going to figure out how to master both.
So every optimization story starts with a problem. But what is the problem, really? See, it's more than just your app crashing. The real performance crisis is when an app, even one that seems totally stable, just feels bad. It feels frustrating to use. That's the real crisis we need to solve.
And this right here is such a critical distinction to make. On one hand, you've got basic stability. The app opens, it doesn't crash, it works. But on the other side is what users actually care about, that feeling of fluidity. We're talking about smooth scrolling, instant taps, animations that just glide across the screen. That feeling of quality, that's what makes people keep your app instead of uninstalling it 5 minutes later.
Now, the most visible, most painful symptom of a performance crisis is this dreaded alert, the ANR, application not responding. This is basically Android's emergency system telling the user, hey, this app is completely frozen up. It happens when the main UI thread gets bogged down with some heavy task. And for a developer, well, it's a giant flashing red light that something is seriously wrong under the hood.
So how do you know if you've got an ANR problem out there in the wild? Well, this is your ultimate report card, Android Vitals. It's sitting right there in your Google Play console, and it gathers real-world data directly from your users' phones. It gives you the cold, hard facts on your ANR rate. Believe me, there is absolutely no hiding from these numbers.
Okay, so we've defined the problem. Where do we even begin to fix it? We start at the surface, with the part the user actually sees and touches, the facade. Let's talk about building a user interface that feels incredibly fluid.
So here's the magic of how Delphi's FireMonkey framework keeps things so smooth. Instead of forcing the main CPU to draw every single button, every label, every little detail, it does something smarter. It translates your entire UI design into a set of graphic commands. Then it hands those commands directly off to the device's GPU, the graphics processing unit, which is literally built for this kind of visual work. The result? The main CPU stays free for your app's logic, and the UI just feels buttery smooth.
A smooth framework is a fantastic start, but you also need fast components to put on top of it. And this is where modern libraries like Alenoi are a total game changer. They offer a full suite of controls built on Google's latest Material Design 3 standard. And these aren't just pretty faces. They are meticulously optimized from the ground up for raw performance.
Just how optimized are we talking? Is it a small improvement? No way. Get this. The specialized string list component in Alenoi can be up to 10 times faster than the standard one that ships with Delphi. 10 times faster. That is an absolutely insane difference, and it really shows you the power of using components that were engineered for one thing: speed.
Okay, so our interface is looking good. It's feeling fast and fluid. But what about all the heavy lifting that's supposed to happen in the background? Now we have to go deeper than the UI. It's time to fix the engine itself, the core architecture of our app.
I mean, this is the classic developer nightmare, right? A user wants to upload a giant 200 megabyte video file. If you try to do that on the main UI thread, guess what? The whole app freezes. Solid. So how on earth do you handle these long, heavy tasks without triggering those awful ANR errors?
The answer is a really clever architectural pattern called the autonomous messenger. The idea is beautiful in its simplicity. Instead of your app struggling to manage a complex background task, you just delegate it. You literally hand the entire job off to the Android operating system itself. This is such a massive improvement over the old way of running a background service inside your app, which, as you know, can be killed by the OS at any moment to save resources.
Let's just walk through this, because it is a complete game changer for app reliability. Your app hands a huge upload to Android and says, hey, you handle this. The user is now free. They can close your app. They can even restart their phone. It does not matter. The OS holds on to that task. When it sees a good internet connection, it completes the upload. And then the next time your app runs, it gets a notification saying, job's done. This right here is the secret to building apps that are truly resilient.
All right, we've tackled the UI, we've fixed the architecture. Now we're going all the way down to the foundation of performance, the actual native machine code that Delphi generates. Let's look at the incredible power this gives us.
So what is this native power I'm talking about? Well, it all comes from something called LLVM. This is the state-of-the-art, industry-standard compiler technology that Delphi uses under the hood. It's this powerful engine that takes your Object Pascal code and transforms it into highly optimized machine instructions that run directly on the phone's ARM chip. We're not talking about interpreted code here. This is true, raw, native speak.
And because Delphi is built on LLVM, you, the developer, get access to this incredible toolbox of advanced optimizations, basically for free. We're talking about amazing techniques like profile-guided optimization, which actually rearranges your code based on how it's used in the real world, and code compaction to make your app smaller and faster. This gives you the best possible performance baseline before you even start thinking about optimizing your own code.
So, we've got a fluid UI, a smart architecture, and a powerful native core. Awesome. But the final piece of the puzzle, and maybe the most important, is measurement. Why? Because you simply cannot improve what you don't measure.
And this is the honest-to-goodness truth of performance tuning. You might think you know which part of your code is slow. You might have a hunch, but without hard data, you are just guessing. Profiling is what turns that guesswork into a science. It lets you find the actual bottlenecks and focus your precious time where it'll make the biggest difference.
So what tools should you have in your belt? The source material points to a fantastic suite of open-source profilers. The Android Studio Profiler is your go-to for checking out CPU, memory, and network usage. And when you need to dig really deep into the system, tools like Perfetto and Systrace are what you'll use to hunt down those super elusive performance killers.
And that really brings us to the final critical question. Look, it's easy to stop working on performance once an app is stable and it's not crashing anymore. But the real journey, the one from a functional app to a delightful one, means going deeper. It means optimizing the UI, rethinking the architecture, and using the right tools to measure what truly matters. So, I'll leave you with this. Is your app just stable, or is it truly optimized to create that seamless, amazing experience that will delight your users and keep them coming back for more?